In this video, we find the absolute maximum and minimum values of a function over a closed interval. So this interval right here corresponds to 0 less than or equal to x less than or equal to 2 pi. That is a description of the interval. Closed interval means it's an interval that includes its endpoints. It's a bounded interval also. And the first thing we are going to do is find critical numbers, also by some people called crit nums, like little critters. They're crit nums. All right, so we're going to find critical numbers, and critical numbers are numbers that are in the domain of the function where, say it's a number c that's in the domain of the function where either f prime of c is equal to 0 or f prime of c is undefined. Now in this case, we could start off looking at what the domain is. The domain's all real numbers. The derivative shouldn't be so difficult. Derivative of sine x is cosine x. The derivative of cosine x is negative sine x. So one thing that we see is the domain of f prime is equal to all real numbers. So therefore, there's no numbers where c such that f prime of c is undefined. F prime of c is defined for all real numbers. So we're not going to get a critical number from numbers where f prime of c is undefined. So we're going to look for our critical numbers where f prime of x is equal to 0. In other words, cosine x minus sine x is equal to 0. All right, that's just going to lead immediately to cosine x equals sine x. Now, you might be possibly fine just getting the answer right then. When is cosine x equal to sine x? But there's some other things we can do. But let me just start with that idea. And whatever happens, I'm going to fall back on the unit circle. So in the unit circle, cosine is the first coordinate on the unit for a point on the unit circle. Cosine is the first point and sine is the second point. So just to sort of, it might not be a good practice, but we're looking for cosine theta equals sine theta so that I can make it clear that theta, or when I say cosine x equals sine x, I'm looking for an angle. And I'm also looking for my angle in the interval from 0 to 2 pi. Now, if given cosine theta equals sine theta, cosine is the x-coordinate and sine theta is the y-coordinate for a point in the unit circle. Now what we can see is where that would happen. We can just look at this, but we should have some familiarity with the unit circle. And we can see though at these points, which maybe I'll put in a brighter color, that the x-coordinates would be the same. So in these two, all right, it depends if I'm pretending you don't know any trig, but anyway, in quadrant 1, both x and y are positive. In quadrant 3, both x, y, and y are positive, or negative, I'm sorry. Both are negative. So they both have the same, they're both positive or both negative. So that's a good start. I can see at those points that the x and y should be the same. Why am I saying that? Because the x coordinate in the first quadrant is the distance along the horizontal, and the y coordinates the distance along the vertical. And so where I've drawn it, the x and y should be the same. And what am I doing? I'm splitting that just exactly in two. What do I mean? I'm splitting the right angle in two. Well, the right angle is pi over 2. Yes, that's 90 degrees. Pi over 2 is 90 degrees. Just different units. One's in radians and one's in degrees. And then half of pi over 2 is pi over 4. Notice I didn't even write down what cosine of pi over 4 and sine of pi over 4. Now, if I go pi over 4 and I add pi, which is halfway around the circle, I get pi plus pi over 4, which is 4/4 pi plus 1/4 pi. That makes 5/4 pi. By the way, another way of looking at this is that we divide both sides of this equation by by cosine x, and we get 1 equals tan x. I mean, many of you hopefully will just know this anyway. without all this stuff. You're like, I don't know what you're doing during this time. So this is tangent theta equals 1. One of the ways I think of tangent theta is think of tangent is for a point on the unit circle, it's the y-coordinate divided by the x-coordinate. Tangent theta is the y-coordinate divided by the x-coordinate. Or it's opposite, for a right triangle, it's opposite over adjacent. Now if you think about it, the opposite or adjacent, or the y divided by x, that's the slope of the line. And I can look at this line that I've drawn, and I've drawn it to make the slope 1, because tangent theta is the slope of the line through the origin, where theta is the angle made with the horizontal, and that slope is 1. So also, without memorizing these coordinates, I can see the slope is 1, so therefore my answer would be pi over 4 and 5/4 pi, because that's where I have the slope is 1. So either way, I'm going to get pi over 4 for x, and x equals 5/4 pi. Now, it's a good point to make that it's not just pi over 4 that gives tangent theta equal to 1. If I take pi over 4 and add 2 pi, which means going around the circle once, I also get the tangent of that angle is equal to 1. The tangent of 2 pi plus pi over 4 is also 1. However, that's not in the interval. We're only looking for between 0 and 2 pi. So 0 is down here in the unit circle. Go around once and you get 2 pi. Okay, so these are our critical numbers, which again, it's possible to write as crit nums. All right, now, what was our goal? It wasn't really to find the crit nums, that was our intermediate piece. What we're going to do is we're going to plot endpoints i.e. means that is x equals 0, x equals 2 pi, endpoints of our interval, and crit nums, which are x equals pi over 4 and x equals 5/4 pi. I could see myself or someone getting a little stuck on this when we have to plot those points. And then, actually, I haven't worked out the problem yet, but once I even find the value, the y values, I have to compare which one's greater and which one's lesser, and that might not be that easy unless I do a calculator approximation, which I sort of don't like doing because it's like, I'd rather see if I can do it without a calculator, even though that might be like I don't know what, too old-fashioned or something. I don't even know what. Maybe it's irrational or not good teaching to say do it without a calculator, but I'm going to see if I can do it without a calculator. Okay, so let's just remember we're plugging into f of x. We're plotting points. A calculator, graphing calculator would plot like 10,000 points or something, I don't know, 1,000, and then the calculator would look to see which one's the greatest. But I don't know if the calculator would get pi over 4, because it would get something very close, an approximation. So let's go ahead and plug those endpoints in. 0 first, that's going to make sine of 0 plus cosine of 0. And we need to, look at the unit circle again. As I said before, sine is the y-coordinate on the unit circle and cosine is the x-coordinate. So it's the unit circle I'm drawing has gotten a lot of, we've gotten a lot out of it. And so it's getting sort of messy. In fact, it's to the point where can I just sort of take away some of the stuff and just focus on that one little point that I'm focusing on, which is, it's 0. So when theta 0 radians, I have that the y-coordinate is 0, so that gives 0 there, and the x-coordinate is 1, so that makes 1. I mean, that's a whole other thing if I'm going to try to explain a bunch of trig at the same time. Just a little bit of explanation, but not too much is maybe not what I should be doing. I mean, for these guys here, whichever way, you get rad 2 over 2 plus rad 2 over 2. A good way would be to draw a triangle, or you could use the inner circle. I mean, these numbers are usually something that people would memorize, but you could write a right triangle, which would, since it's pi over 4, corresponds to 45 degrees, which gives a, that's this 45, 45, 90 triangle, and you can use the Pythagorean theorem to get these side lengths. And so sine of 45 degrees is opposite over hypotenuse, that's 1 over rad 2. Cosine 45 degrees is also 1 over rad 2, and both of those, when you rationalize the denominator, will give us rad 2 over 2. Again, it makes the problem seem way longer and more difficult if we spend a lot of time trying to remember what these values of the special angles are. So that's just, I don't know, that's sort of the way it goes. But anyway, f of pi over 4 would be, we already did that. F of 5 fourths pi, that's another critical number, is sine of 5 fourths pi plus cosine 5 fourths pi. And these guys will have the same values of sine of pi over 4 and cosine pi over 4, because on the unit circle, they have the same reference angle, which is pi over 4. But we are, as we pointed out last time, that's in quadrant 3 where we have 5 fourths pi. And so in quadrant 3, for 5 fourths pi, we'll still have the rad 2 over 2 and the rad 2 over 2. However, both of those will be negative, because it's just simply by looking at the plane, the y-coordinate is negative in quadrant 3, and the x-coordinate is also negative in quadrant 3. So I'll have negative rad 2 over 2 minus rad 2 over 2, which makes negative 2 rad 2 over 2, which makes negative rad 2. So, I mean, I thought I might have some trouble evaluating, but I can clearly see the negative rad 2 is the least of these three numbers, because the other two are positive. And the other one that I'm going to look at is the endpoint 2 pi, and that gives sine of 2 pi plus cosine 2 pi. And sine of 2 pi is the same thing as sine of 0, and so is cosine 2 pi, because it occupies the same place on the unit circle. So that's going to be 0 plus 1, it gives 1. And therefore, we can compare. Now, square root of 2 is greater than 1. That's just simply true. And because, look, 1 is equal to the square root of 1. So we have square root of 1 is less than the square root of 2. And square root of 1 is 1. All right, so what I have is I have the maximum, which more, I don't know if I'd say formally, but more complete statement would be absolute max, and then negative rad 2 is absolute min. So let's do absolute min. Like Minnie Mouse, it's tiny. Minnie Mouse is tiny. That's negative, that's the smallest. So I'm saying that to help maybe someone who's an international student who is not familiar with the word minimum. I think you are though, but minimum, maximum, they both starts with N. Minimum is Minnie, like Minnie Mouse. Okay. Absolute max is going to be at pi over 4, apparently. Or maybe I got them exactly backwards. No, I think I got it right. Okay, is equal to rad 2. So that's our greater of those three numbers, or four numbers there. And then, well, why don't I sort of cheat, because I like doing this anyway, and look at the back of the book. This is Openstax Calculus Volume 1, and that's free for us to use, but not free for us to sell. Absolute max is, it says right here, is pi over 4, and that's at x equals pi over 4, we get y equals square root of 2. Absolute minimum, x is 5 fourths pi, y is negative rad 2. So this is from Openstax Calculus, and this is section 4.3, number 127. Sort of funny numbering, in my opinion, in that book. And but this is all from Openstax.org, and this is Calculus, Volume 1, Section 3.4, number, what was it? 127. See what's going on? This is a grant by some top people in organizations. It's not just like some. It's there's some big you can check out who's behind it. And the OpenStax organization has an affiliation with world-class university, Rice University in Houston, Texas. Beautiful campus. I think Philip Johnson, great architect, designed some of the buildings there. Definitely worthwhile seeing. Houston, fantastic city, great art district. Okay, and of course, Space Center. Great food, great people. Okay, anyway, that's totally off track. Openstax.org. It's open source. Why should education cost money? I mean, you make a calculus book, and especially, anyway. So, I mean, it's free. Okay, but all right. So that's all. Bye.